In 13.2, we have 3 formulas. The same formula is used for a prism or a cylinder. The only difference is sometimes your base is going to change. So what that means to you, if you have a prism, doesn't matter what the prism is. If the bottom is a square, you're going to do something with the area of the base. If the base is a square, you're doing like the length times the width, or the base times the height of the square, multiplied by the height of that prism. If it's a triangular prism, I'm going to try to draw that a little bit better. And you have a triangle as your base, you might have to do 1/2 the base and the height of the triangle multiplied by the height between the two bases. So this big B changes depending what the base that you are working with. If it's a circle, then this base is a pi r squared. You might have big B as pi r squared. It just depends what the base is. So in each of these formulas, when you see big B stands for the area of the base. Sometimes the area of the base is going to be a triangle. You're going to use this of the triangle. Sometimes you're going to use this, which is of the rectangle. Sometimes you're going to use this, which is of the circle. Now, with that being said, I have 2 videos that I want to show you. My internet's not working right now with the Wi-Fi for whatever reason, so I'll show you after the recording of these 2 videos. I think it's pretty darn neat to see why these formulas work. That's what you'll see right there. It deals with liquids and solids, and I'll show you that in a second. But the formula for prisms and cylinders is big B times H. For a pyramid or cone, it's the same formula, except you have a 1/3 times big B times H. Big B still can switch depending what the object is. And then a sphere is the only one with r to the 3rd power. So volume's 4/3 pi r cubed. Keep that in mind. Man, I'm sorry. I'm just not feeling great today. When you have H is always the distance between 2 bases. H is always perpendicular to the base. They will try to trick you. H is the perpendicular height. And sometimes they're going to give you the height on the outside of the shape. Since it's the perpendicular height and not the slanted height, like this, sometimes you will have to use the Pythagorean theorem to figure out what H is, like numbers 3 and 6 in your homework. Number 3, they don't give you what H is. They give you the slant height. But if you look, there is a right triangle inside this pyramid. The base is a square. You can figure out what this distance is and use the Pythagorean theorem to figure out what H is before you start your problem. And so I think that explains everything. We're going to do some examples. I have chosen 3, 4, 10, 12, and 15 for us to do together as a class. If you have any questions, you can stop me, but let's just get into it because I don't know how long my voice is going to last. It says find the volume. It's a pyramid. First thing I do is write down my formula for a pyramid. 1/3 big B times H. I know that the base is, and I look at the shape, and the shape is a square, 10 feet by 10 feet. The formula for the area of a square is length times width or base times height of the square. It's a 10 times 10. The height, they did not give me. They gave me the slant height. They're trying to trick me with this 13. So I need to figure out what the h is by using the Pythagorean theorem. The sum of the square of this leg plus the square of this leg should equal the hypotenuse squared. 5 squared plus h squared should equal 13 squared. I set it up that way on purpose because the h is the hypotenuse of this triangle is 13 squared. 169 plus 25. Yep. Subtract 25. H squared equals 144. Square root, square root. My h is 12. Which means now we can actually plug that in and figure out what the volume is. Feel free to plug this whole thing into your calculator. If you don't have a calculator, you can do it by hand. But we have fraction buttons on our calculator. So I'd recommend doing fraction button, 10 times 10 times 12, and just seeing what you get. Or if you're doing it by hand, 3 goes into 12 4 times. 10 times 10 is 100, so I can tell this is 400 feet cubed. Any questions? Number 4. Now, I did not give you a formula for number 4. Number 4 is called a hemisphere. It's half of a sphere. I gave you the formula for a full sphere, and what you need to do is apply your common sense to the formula, because if the volume of a whole sphere is 4/3 pi r cubed, you only need half of 4/3 pi r cubed. We're going to do half of this whole thing, right? So, just in case you have to do that later, here's how I would do it. Half of 4/3 times pi times r to the third power. R is 7 to the third power. That'll be my volume. You can punch this whole thing into your calculator. You're rounding to the nearest tenth anyways. I understand your pain. I feel it. 1/2 times fraction button. Oh, too many fractions. 4/3 times shift pi. 1/2 times 4/3 times pi times 7 to the third power. That's what I love about these calculators. They have the fractions, they have the pi buttons, and then sometimes you have to switch it to a decimal anyway. So I'm using that SD button to the nearest tenth. Which means the whole sphere is going to be like super big, but this hemisphere is only 718.4 meters cubed. And it should make sense because what you're doing with this distance here, 7 meters, you're taking it to the third power. That should let you know, your units are meters cubed. Number 10. Number 10 is a prism. But the prism has a hole in it. Looks like it has a rectangular prism that is taken out of this almost a cube. It's not quite a cube because it's 4, 3, and a 4. So what I can do is I can find the volume of the bigger prism, the outer, And I'm going to subtract the volume of the missing prism, like this stuff on the inside. So the volume of the outer prism, here's the base and the height and the other height, or the length times width times height. That will be 4 times 3 times 4. If I think about this particular prism, I have a 2 feet and a 2 feet, and this distance must match this distance, otherwise it would not go all the way through. So I see a 2, and a 3. It's basically, I'm taking the volume of the everything and I'm subtracting this blue volume, which definitely is not there. Now I'm going to work out the problem. 4 times 3 is 12, times 4 is 48 feet cubed, minus 2 times 2 is 4, times 3 is 12 feet cubed, which comes out to be 36 cubic feet. I was trying to think of an example in real life where you would need to know how to do this. If you are putting in fence posts and you're trying to calculate how much concrete to put in, and you have a fence post that's going to push out the concrete, you're putting the bag around there, you might be able to, you might find this helpful. Not sure. Number 12. I chose the last two problems from the back side of the worksheet because the back side is going to do a couple things. It's going to ask you a couple of word problems, and then it's going to ask you to find missing information. One of which, there's a typo or something. I think there's one of the questions, I forget which one it is. Let me look at this piece of paper right here. That you might just be given the answer. Number 19. Number 19, they give you the answer. You don't have to do any work. Lucky you. We know, I saw it. It's a typo. It's lucky you. Okay, but here we go. Let's do number 12. Sphere A has a radius of 5 feet. We'll call this sphere A. Sphere B has a radius of 10 feet. Compute the volumes of each. How do the two volumes compare and be specific? So they double the radius and they want you to know what is the difference. What change does that make in the volume? So let's figure that out. Volume of A, 4/3 pi. Instead of r, I'm going to plug in 5. 5 cubed. Volume of B, 4/3 pi. Instead of r, I'm going to put in 10 cubed. I'm going to see what that's equal to. 4/3 times pi times 5 to the third pi. Oops, that's not what it's supposed to be like. 4. Oops. Now that I get it looking exactly like it is on paper, this is 500 pi, which is about 523.6. Delete. I like just changing one number. It's kind of nice. 4,000 thirds pi, which is about 4188.8. So we computed the volume. I have the volume of A, I have the volume of B. How do the two volumes compare? This is bigger than that. Is it twice as big? Then it'd be 1,000. No, it's more than 1,000. What do I have to multiply the 500 by to get to the 4,000? I have to multiply this by a number to go from here to there. This is how much times bigger? Volume A compares to volume B. 1 to 8. This is 8 times bigger. 500 times 8 would give you 40,000. If I take this and divide it by that, it would give me 8 or something really, really close to 8. What's interesting to me about this is that by doubling the radius, what happens is your volume increases by 8 times, which should make sense because even though you're doubling it, you're cubing that in the formula. 2 times, or 2 to the third power, comes out to 8. That's a huge difference, right? Like, it's a lot bigger than that. Not just 2 times bigger, but 8 times bigger. I thought that was a neat question. Last question. Number 15. Volume of cone is 300 pi inches cubed. Height's 9. What's the radius? So the first thing I do is write 1/3 big B times h. In this particular shape, since the bottom is a circle, I'm going to replace big B with pi r squared times h. And now I'm going to start replacing it with values. Volume is 300 pi inches cubed. 1/3 pi. Do I know what the radius is? No. Do I know what the height is? Yes. So I plug everything in that I know. Then what I'm going to do is I'm going to rearrange, because I can multiply in any order that I wish. 1/3 times 9 times pi times r squared. And I know what 1/3 of 9 is. It's 3. The 3 pi is multiplying the r squared. So the opposite of multiply is divide. I'm going to divide both sides by 3 pi. Pi goes into pi 1 time. 3 goes into 300 100 times. Then I square root to get the r by itself. The square root of that, something times itself, is 10 inches for our answer. And that's where I'm going to end your notes.